And so with that, I'll go ahead and take it away.
Thank you. We are here to give you an insight in how our toolkits has affected our development process when we are developing NSO projects. My name is Jesper Sigården, and I have been an NSO developer for like 10 years. Started out as a service developer, and now I'm more of the web UI developer.
My name is Kristoffer Hansson. I've been working at Data Ductus for 5 years and been working since then with NSO service development mostly.
Okay, so who is Data Ductus? We are a company that was founded in 1989 in Stockholm, Sweden. Today we are more than 250 employees across the world. We have offices in Sweden, USA, Singapore, and Japan. We have been working with the NSO since it was born, and today we are roughly 50 NSO developers offering our services across the NSO platform. That includes project management, service development, and self-service portals. We like to work with in an agile manner with the customer. When we were introduced to the NSO, we immediately saw the potential with the product, but we also saw the complexity with it. After our fair share of do's and don'ts, we started to see a pattern of challenges, and the major ones are testing. Tests took too long time, and it was hard to reach the code coverage that we wanted. There was a steep learning curve that made it hard to onboard new resources, and there was a lot of repetitive coding, resulting in much coming from copy-paste errors. Performance leaks, as we call it, performance issues, due to limited understanding of how Navi and MAPI interact with the NSO. It was there we started our work to get better quality and higher consistency.
So we approached this challenge in a few different ways, starting looking at the organization, team onboarding, but also different kind of development methods such as the test-driven development and behavior-driven development. But mostly we introduced the lazy programmer, which led us to implement tools to help us get along. And that's what we're going to talk about here today. And mostly the four on top here, the NSO tools, the unit test framework, code generator, and the web UI toolkit.
Okay, when we started with the NCS, as it was called back then, the APIs was not as good as they are today. There were no packages, no lifecycle management, no application components, just manual code. A lot of work was going in to handle transactions and subscriptions. The Navi utility classes did not cache as aggressively that they are doing today, and just turning a key path into a next path was a challenge. The NSO started with MAPI channel, a diverse utility that mimics the Java MAPI, but it handles the transaction management internally with Java's try-read resources. It quickly grew with utilities such as fetching multiple values in a simple way and making the query API more accessible. The MAPI path create paths by method chaining. Oh, sorry, I was on the long slide. Whatever. So, during the development of NSO tools, we also saw a problematic pattern when developing services. Complex mapping code read values throughout the service code without regard that one read was a socket connection towards the NSO. And this became what we call a performance leak. We devised these ways of working with the help of MAPI reader and MAPI writer to make the developer mindful of how the service code interact with the NSO. We first select and read the data that the service need to do the mapping. Then we collect the changes of the service into a MAPI writer, and then we write the values in one call. So some code examples. As I stated before, the MAPI channel mimics the Java MAPI, and its primary purpose is to handle transaction. It will keep track of how you created it and finish the transaction if it needs to. The secondary purpose of the MAPI channel was to encapsulate helper functions, like a way to get list keys the most efficient way, or getting multiple values in one call. In this particular example, we create the system API, we set the value, and we commit the transaction. Something that we missed was a easy way to get multiple values from the NSO. What happens behind this snippet is that it builds a config.xml param structure and performs get values from in one call. And the result is packaged so that the developer can easily access them. The query is a very powerful tool. It can extract data from the NSO, but the API is hard, and there are not that many examples to rely on. So with the query class, you just give it the entry point, and you build the query by method chaining, and you get an intuitive result. One of the most bloated and copy-pasted code we had was the subscribers, and we finally landed in this implementation. We have a subscriber base that do the heavy lifting, and it's pretty simple, if you ask me. We also have an advanced subscriber base, and there you get the old value and the new value in the change as well. The MAPI reader is an evolution of the get values implementation in MAPI channel. It constructs an object tree of config.xml params that is used to get the values from the NSO. It's a two-stage rocket. You first build a request tree, and then the second stage builds the config.xml param tree and gets the values from the NSO in one call, in as few calls as possible. And accessing the values is as easy as building the tree. And the MAPI writer, it mimics the MAPI reader. And you collect your changes you want to make, and then you write the changes. You can write it as a simple write or a shared write/create.
Okay, since the beginning of our old projects, we have strived to have as much test as possible. And from the start, we used Lux for northbound testing, mostly towards the CLI. This took a long time to run all the test suites, and with higher code coverage demands, it's starting to get complex tests, and they took long time to develop, and they took long time to execute. So we started to look at the options, and back then we had a few unit tests that test code that wasn't dependent on the NSO itself. And we naturally would like to extend that into the NSO code as well. So that's when we started to develop the unit test framework. So what is the unit test framework? We call it the NSubTest Tools. It's essentially an NSO simulator. It gives us the possibility to write to a mock CDB with transaction handling directly from a very boxed environment. So we can run service code, we can run call points, we can run any kind of NSO code that we would like. It gives us the benefits of integrate to the IDE. We can debug directly in the IDE, and we can get all the changes through the CDB verified. So it will actually detect unverified CDB values and tell us that we need to verify it or remove those kind of side effects. It works for both Java and Python, but keep in mind that this does not replace the end testing and use cases. So show a short demonstration of this. I've been pre-recording this, so let's see a video. So just implemented a very basic service. This uses the Okay, so can we go?
We have been struggling with this.
Yeah,
Anywho.
and this is not my computer. I'll blame that. I'm not sure how to go back. Do you know? Let's go back to the previous slides. So this is the service code. It's has a basic service which has a customer list, and under each customer we have an information leaf. We are copying it to a root container which has the same kind of customer list, but in this case it has a leaf called description. So let's go and see the test we have written, the unit test for this. So at this stage, we can see that we have three parts. We have the setup, which is actually setting up the CDB values that we're going to be read from the service. We run the code, which is executed through a helper function just to give us the mocked nav containers and stuff like that. And we verify the values in the end. So let's run this with code coverage to see that we get the coverage in the IntelliJ setup we have here. We can see what codes that actually have been executed. So as we can see here, we have the coverage at the left side, where we have one untested line, which is expected since we haven't written any code for the exception handling yet. But this gives us a hint on what to test next. And what we said earlier was that we have this behavior that we can get notification on unverified CDB value operations. So let us just remove one of the verification lines and see what happens in the test case. Oh, I started it over. That wasn't mine. So we remove the verification row and we just rerun the test. And we expect this to fail because we said that we should warn us about this. So what we can see, it says that we have unverified values in CDB. It actually gives an example on what to verify. So at this point, we need to understand if this is an wanted behavior or if it's on some side effect that we're not aware of. So either add this or fix the code itself. Okay, so despite all the NSO tools Jesper just told us about, we still had a lot of repeated code and wide range of errors, mostly due to many junk changes during the projects. It still was kind of hard to understand when and where for new people to use the NSO tools. So we wanted a better way to handle this. We came up with the code generator. It generates code from the last junk changes or the latest junk. It can generate skeletons for all the call points, so we get a skeleton for the services, all the actions and stuff like that. But mostly we get methods or classes for all the junk structure. Very similar to magic in Python. But we get a benefit of compilation errors instead of runtime errors. This also gives us the possibility to have auto-completion in IDEs and stuff like that, so new team members easily understand what they can do and when they can do it, which gives us high code quality and shorter lead times. So I'll show you a quick demonstration of this as well. So I've just taken the same code as in the previous test, but I'm converting it to the generated code. And as we can see, back to Jesper's presentation, we are doing a read at the first just to optimize the reads. We are reading the whole service data. We're mapping that to the new target and we're writing it. And just to have something to compare to, I've written the same thing in Nova as well, just to see what kind of different. Oh. So here we have the same services in Nova code as well, but with namespace files, just to show you which type of errors we can find and what we can gain from this. So let's go to the Yang and just change the leaf into a new container. So we are moving the info leaf into a description container, just to gather it for some future purpose maybe. So let's run this, rebuild this code, and see what happens. So as we can see, it says that something failed. So let's go and check the Nava first, just to verify that this is still doesn't say anything wrong. It seems okay. So let's go to the generated code, and here we say that it shows that the info is not valid. So let's type a dot, and it says that, oh, you should add description here, and it works fine. So let's recompile this, and everything should be fine, except for that the Nava implementation will actually fail at runtime when we start using our tests on this. Or hopefully we'll catch it with the tests.
Okay, so the Web UI Toolkit. When the NCS 2.0 was released, they also released a Web UI framework that utilized the schema to auto-generate the pages, much like the NSO has today. The implementation of the framework grew and became too complex to efficiently maintain and was deprecated in 3.0 and then discontinued in 4.0. The NSO today is released with an excellent UI. It can auto-generate the UI from a Yang model, show you lists, and you can create, edit, and delete configuration. But an auto-generated UI has its challenges, where the biggest one is that it's rendered from the Yang, often in Yang model order. So unless your Yang architect is a user experience expert, the UI will come very hard to navigate. What an auto-generated UI also lacks is the interfield communication, where so it solely depends on the validation, the NSO validation process to show you errors. In the gap between the default UIs of the NSO, there was a void to be filled. Customers still wanted a nice UI for the services, and UI that not only can handle a basic management of alarms and devices, but also a custom UI for their services. We started with our implementation and of the portal, and we faced similar problems as the other projects. We have a steep learning curve where the developer must focus on the API instead of look and feel and user experience. And we had a lot of repetitive code, especially in forms. So today, the NSO Data Ductus NSO portal is a complete toolkit for building and maintaining portals for customers. For our production environment, we use the Engine server as proxy and static file server. In the current version, we have an alarm management, device management, and transaction management. To create the portal, we have created components for each of the Yang types, and we test each of the type with unit tests. Some Yang types are represented by multiple components. For example, the list type, depending on complexity and how you want to integrate the list in the form. In the beginning, we created forms by hand, a tedious and error-prone labor that rendered in a lot of copy-paste bugs. Building a custom UI today consists of 5 steps. Acquire the customer's use cases, apply the customer's look and feel and branding, build a form with the help of Yang information, transferring the restriction and dependencies from Yang to form, when expressions, display when, and so on. And then we create tests to verify the UI. So today we're using schema information to generate field configuration, complete with label name, type validation, and server connection. And then we build the forms just like Lego, field by field to customer-specific UI according to the use cases. Okay, to sum it up.
Okay, so what was this outcome of the internal work we have been doing? So we have earlier error detection due to a lot of things, but mostly due to generated code. We get less human factor errors and better code quality due to this. This leads to shorter lead time. We can focus more on the features instead of the bugs. New team members are much easier to onboard. It takes a lot less effort for our senior developers. But mostly we get innovation by our engineers, get happier customers, engineers, which makes us keep the core knowledge into the team. And that makes it possible for us to today have one of the world-leading development solutions of the NSO product.
So what started as an embryo has grown through ingenuity into foundation of our development process. So how do we do it? We used retrospect. We analyzed the finished project and it identified areas to improve. We analyzed our errors and bugs to add features and functionality to stop us from repeating them. We used knowledge sharing. We set up meeting across offices to share our experiences. So the result is unmistakable. Over time, our efficiency has increased, whilst the project cost and time has decreased. Here we have 3 projects of similar size. Each of the projects has challenges, but the overall efficiency has increased. These results are also can also be applied to the web UI development team. So, like all tools that are experience-based, they continue to evolve, and we see that we are going to incorporate utilities for nano services, more integration into IntelliJ IDEA, and the test framework are going to begin to work on testing with Navu. Yeah. So that concludes our presentation. Are there any questions?
Yeah, if there are any questions, let me know. Wave at me. Got it. I see one over here. Then we'll get back. Sorry.
Hello. Yeah. So I have a question regarding to I think one of the slides you mentioned you were actually validating or testing the NSO CLI, right?
Yeah, I mean, we are not testing the CLI, but we're testing our code through CLI.
Yeah, so which means not only NSO installed, but also you would have a customized package installed with your own service, right? When you're testing the CLI.
I mean, we are using the regular CLI of the NSO, so we just need our service code. We write these set commands as you would do manually, but from Lux instead.
So do you use any NetSim devices for your testing, like NetSim simulation?
So we mostly use NetSim devices, like almost always NetSim, yeah.
So basically, this validation is regarding to the service you write.
Yeah, I mean, we try to cut off as much as possible dependencies either way to shorten our lead times, but we still have a lot of time spent on tests.
So basically, it's Lux test on the NetSim devices, right?
Yeah.
Okay. Thank you.
Okay. Okay. I see your hand. I'm coming.
So regarding the tests, we had a project that we had Lux tests, and those tests took 8 hours to run through. Yeah,
It took over 8 hours to
yeah.
run.
And then we did a JUnit implementation of that.
I think it took less than 20 minutes to run those kind of same set of tests.
With better code coverage.
I mean, we strive to have as much as possible, around 80% at least. But I mean, depends on type of code you're writing and such.
And it's, I mean, just to get the integration of into your development environment is.
Yeah, I mean, it speeds up the development as well, since I can debug and run just my code in the development environment without even starting the NSO. I mean, starting the NSO takes some time, but just that.
Got another question right here.
Yeah, if I understood that correctly, you're pretty much consolidating multiple commands, let's say, or executions into a single MAPI channel. Was that correct?
Yes.
Okay.
In a way.
Okay. Yeah, I mean, is that just like a logical layer on top, or you actually do? What's the performance of it?
Okay, so it started out as a we wanted to have better performance due to that the Navu did not cache data at all. So we created the MAPI writer to and we mark what we want to read, and then we build a request of that and send to the NSO, and we get the data back. So it performs one call or as few calls as possible, because you can mark that I want to go to this list, I want all elements, and I want these leaves from that list. So then he has the reader automatically goes and collect all the list keys and constructs the conf XML param tree, and then get all the values. So it's pretty efficient.
Yeah. Okay. I was more like if you have any numbers, like how much better is it, or I mean, it depends on the particular use case, obviously, but maybe some rule of thumb numbers.
I know that we've done some verification, but it's been a while, and now it's improved a lot, I would say. So it's getting better, but depends on how much you do the excessively reading, how much you reuse the leaves. If you read them once and you just read a very low amount of leaves, you're fine doing it the same way you're doing today. But we have huge projects reading used data structures, so we need an optimal way to do that.
Yeah.
Okay. Thank you. Other questions? One hand over there.
Do you have any tools for Python, or is it only Java-based?
I think that the Magic implementation is quite okay there. The only thing we don't get with that is the compilation time error.
That was where I was going.
Yeah. So we have been thinking about that. We haven't yet seen the need for it. I mean, we can write the unit test for the Python as well, which will for us verify the structure, because we're verifying the whole schematics at that time for Python.
Thank you.
Okay, thank you. Anybody else? Okay, last chance. Any other questions? Okay. All right, then I have 3 things for you.
Cisco, the bridge to possible.